So in this part, we're going to be graphing a restricted function. So here's the question. Sketch the graph of the following function and state its range. So we need to sketch it and we need to state its range. Here it is. And as you can see, it's written in our standard function notation in which our domain is given, our codomain is given, and then the rule is given. Now, I'm going to answer this both with and without the cas, and it's important that you can do it both ways. So let's begin without the cas. So if you were asked to sketch this without the cas, what do you think the first thing you would do is? Well, I need to get a sense of how I would draw this thing. I can immediately see that I can factor out an x. So I'm going to do that. I'm going to take x out, and that's going to leave me with x plus 1. From this, I can identify my x-intercepts, can't I? Because I know that I can set this equal to 0, and I can set this, x plus 1, equal to 0, which means x is going to be equal to -1. So I can come to my graph here, and I can say that I'm going to have an x-intercept at -1 and 1 at 0. I also know that it's going to be a smiley face parabola because I've got a plus in front of my x squared there. So I can come and I can draw this, and it's going to look something like this. Oops, let me try that again. Okay, it's going to look something like that. But now we need to be careful because at the moment, what I've drawn is a domain of all real numbers. It exists for all the values of x. But as you can see here, we have a restricted domain. My domain only exists between -1 and 1. So that means my x values only exist from -1 to, let's say over here is 1. So that means this part of the graph doesn't exist, and this part of the graph doesn't exist. It's going to end here and end there. So now what I have to do is I need to figure out what these endpoints are going to be. So what are the y values that correspond to these endpoints? To do that, I'm simply going to sub some things in. So I'm going to go, I'm finding the endpoints. So let me just label it. So if I'm finding the endpoints here, I'm going to go, what's f of -1? Now, what was my rule again? I've forgotten. It was -1 squared plus -1, which is going to be -1 squared is just +1, -1 will be 0. Then f of 1 will be 1 squared plus 1 is going to be equal to 1 plus 1, which is 2. And that makes sense. It makes sense that this right here is -1, 0, because I'm there. It's on the axes, and this would be 1, 2. Perfect. And I'll label this as well, 0, 0. So not the prettiest looking graph, it should look a bit smoother. Okay, that's okay. Oops. We're gonna have to live with it. There we go. So I have given this a nice sketch, but it says I need to state the range. Now, remember, what is the range? The range is all the possible y values. So to find that, I'm going to have to consider what my turning point is going to be, because my y values are going to go from there all the way up to here, which is going to be 2. So I need to figure out what this is, because then that's all going to be my y value. So how can I find what this turning point is going to be? There's a couple of different ways you could do it. You could use, to find the turning point, x is equal to, and then hopefully you all remember the formula in which to do this, which is -b on 2a. So I can just go, all right, what is x going to be? Well, -b in this case, or b, would just be the number in front of x. So it's going to be 1. And then a would be the number in front of x squared, because remember, this is just going to be ax squared plus bx plus c, right? That's what we're dealing with. So that's why my b value is 1 and my a value is also 1. So I'm going to get 2 there and a 1 there. So that means it's going to be -1/2. So I can come here and I can say that the x value of this is -1/2. And then what is my y value going to be? How can I figure out what the y value is going to be? Well, I would have to sub in -1/2 into my rule. So I'm going to go f of -1/2 and I might do this a bit quicker. I'm going to, oh no, let me do it slowly. Let me do it slowly. Plus negative a half. Well, hopefully you're not running out of room like me. Now I'm going to change this to 2 on 4 to get my denominators the same, which means at the end of the day, what I'm going to be left with is negative 1/4. So I can come over here now, and I can say this is negative 1 on 4. Perfect. So that means my range, now where will I write this? I'm going from negative 1 on 4, that's a funny looking, negative 1 on 4, all the way up to 2. So it's all a bit of a mess here. There is some logic to it, you know, you can see my x-intercepts, you can see my endpoints, you can see my turning point. And what I need to list out as my answer is the range. So let me just come up here and go, the range is going to be, y is an element of negative 1 to 4 all the way to 2, like that. So that is going to be the range of the graph. So negative 1 to 4 to 2, they're all the possible y values for this function. Okay, having now done this all by hand, I now want to go through how to do it on the CAS calculator. But this part has already gone on for a bit too much, so I might pause this video here, and in the next part, we'll go through this question again, but just quickly go through how to do it on the CAS.